All right, welcome back. This is cycle 6, day 5. So we're moving on to the Pythagorean theorem. But before we do our lesson on the Pythagorean theorem, I have an EQAO question that I'd like you to try out. So this EQAO question goes like this. So it's a TV question. If a TV is 41 by 71, let's say inches, because I wouldn't think of a TV as 41 by 71 centimeters. So 41 by 71 inches, what is the dimensions of the TV? All right, so if it's 41 by 71, what is the dimensions of the TV? Now, whenever you go into buy a TV, they always tell you the diagonal length of the TV. So if you're going to go buy a 5-inch TV, that means from corner to corner, from top corner to bottom corner, it is 75 inches. So here you're going to have to figure that out. You're going to want to use a squared plus b squared is equal to c squared. Right, so if you did have a TV, I'll even set it up for you too. If you had a TV that's 41 by 71, can you figure out this length? Can you figure out a hypotenuse? So pause the video and give it a try. Alright, hopefully you have a squared plus b squared equals c squared written down. Your 41 squared in either your a or b, doesn't matter which way it goes, as long as your c squared is your longest side. So c will be our longest side, the hypotenuse. And we've done questions like this, but not in too much detail, but we have 41 squared plus, and then we have 71 to the power of 2 is equal to, so we're going to get that value, 6,722. Is that how many inches that TV is? Does that make sense? No, what do we have to do with that number? We have to take the square root. 6,722 gives us 81.9. So maybe let's say 82 inches is equal to C. Therefore, the TV is 82 inches. All right, that little dash just means inches, or you can write the word. Perfect. Okay, so that's pretty much what we're doing today is the Pythagorean theorem. Right. So if you need to pause it, go ahead and pause it. We're going to move on to this. Make sure everybody has cycle 6, day 5 out in front of you. All right, so working with the person beside you, complete the following investigation. Use your device and each other. So look at the following diagram. What is the diagram trying to show? Explain in words and using a formula. So what is it trying to tell you? Go ahead and press pause and see if you can come up with anything. Well, hopefully you can see that this has 3. So this is like a length of 3, this is a length of 4, and here we have a length of 5. We can also see that this is a 5 by 5 square here, and 5 times 5 gives us 25. We can see that this is a 4 by 4 here, and 4 times 4 is 16. The area here is 16. And this is a 3 by 3, giving us an area of 9. From that, hopefully we can see that 9 plus 16, so this blue one plus this orangey red one, let's just go with this color, gives us, what's 9 plus 16? Hey, that's 25. That gives us this green color that's right here, showing that the square areas of both of those sides equals the area of the longest side. So that's super important, and that is actually right from a squared plus b squared is equal to c squared. 3 squared plus 4 squared is equal to 5 squared. This is also really interesting. It's the only one that does this. This is the 3-4-5 rule. So anything that's 3-4-5 or a combination, even if it's like a growth of 3-4-5, so let's say 6-8-10, all what we call the 3-4-5 rule. This is used a lot within um, construction and a lot within building houses and things like that. So does this formula work for all triangles? No, it only works for this type of triangle, 90-degree or right angle triangles. All right, what does the word hypotenuse mean? Labeled by hypotenuse in the following diagrams, how can you remember what side is the hypotenuse? So what does it mean? It means it's the longest side. And then label the following. So here I'm going to help you out with this one, and you're going to try the next ones. How to find the hypotenuse it's always across from your 90-degree angle. So whatever the side length is across from your 90-degree angle, you label that C, and then it doesn't matter which one's A and B. Right, so again, when we go across, this actually should be C, and then this one A and B. And go across, this would be C, A and B. Maybe even pause the video so that students can try that out. This is C, this is A and B. Right, we're going to look at 3 and 4, and we're going to determine the formula for the missing side for both of these equations. So for question 3, we have this triangle right here. So this triangle right here has A, B, and C. So we have A squared plus B squared equals C squared. We can see here that we're trying to find the longest side. We're trying to find the longest side. That means we're always going to add the two smaller sides squared. So 6 squared plus 9 squared. Let's go ahead and figure that out. I want to point out that this is not 6 plus 9 squared. Okay, this is 6 squared plus 9 squared. So we get 6 squared, which is 36, plus 9 squared, which is 81. So 36 and 81 gives us 117. So 117 is equal to x squared. And then, yes, we need to, this question below is just asking us to find the measurement. We have to take the square root. Right, so again, we're not doing 6 plus 9 squared. 6 squared is 36, 9 squared is 81, and then you add those two together. We don't do 6 plus 9 and then square. It's not 15 squared. Right, that's a common mistake. So here 117 square rooted gives us 10.8. So we get 10.8 for question number 3 and question number 4. For question number 4, we can see that we are not looking for the longest side anymore. And since we're not looking for the longest side, we're going to have to subtract. We're going to subtract the longest side from the smaller side to get the other side. You can also set up the equation as a squared plus b squared is equal to c squared, and then rearrange. Or you can use, if you're more familiar with it, you can use the c squared minus a squared is equal to b squared and jump right into that equation. But if you're not familiar with this, I highly think you should just remember this equation, and from there you can easily get this one. So let's take these values. C is 12, so 12 needs to go in for C. That's the longest side. A is 8, so we're going to put 8 in for A. 8 goes here, plus B squared. We're going to jump that 8 squared over to the other side with a 12 squared. And there we go, we have the exact same formula here, except numbers in it. And it's subtracted. So if you're looking for a smaller side, you subtract big minus small. If you're looking for the longest side, you add those two smaller sides squared. Okay, so this is 144 minus 64. I'm not sure. And that gives us 80. Yep, that makes sense. And is that the smaller side? Is the smaller side 80? Oh no, because the longest side is 12, so you have to take the square root. The square root of 80 is 8.9. So we get b is equal to 8.9 units. This is also units. Right, those are the measures of those two side lengths. If you need to pause at any time, go ahead. Right, for this question, I'm going to pause it and let you try it out. But how high off the ground is the owl? Sorry, that should say is the owl. Go ahead and try that using the formula that we just used for this question number 4. So here we're not looking for the longest side, we're looking for a shorter side. Go ahead and try it out. All right, so here we are. A squared plus b squared equals c squared. So I labeled my triangle C, A, and B. It doesn't matter where your A and B goes, but 100% matters where your C goes. Your C is always right across from the 90-degree angle, so that's the longest side, the hypotenuse. Right, so I labeled it A, B, and C. I have my A, which is right here, just listed as A. B I have as 12, and C I have as 43. Right, then I jumped that 12 squared over on the other side, did 43 squared minus 12 squared, and got 1,705. Then I took the square root. You take the square root of this side, you're also taking the square root of this, a squared. And the square root and the squared of a value, they reduce to just give you a. So that's why we no longer have a squared on our a anymore. And we get our final answer as 41.3 feet. If you got that, give yourself a check mark. All right. Mr. Tolton just bought a new TV that measures 24.5 inches by 43.6 inches. Can you go and label those on the TV? And then we have the size of the TV screen is determined by the diagonal. All right, so we need to calculate the diagonal, and let's go ahead and look at that. Mr. Tolton tried to calculate the length of its diagonal below. All right, so let's calculate the diagonal. Since this is the length, then we have 43.6 because that's the longer side in inches. And this one's our 24.5 inches. Will we be adding or subtracting here to find the hypotenuse? Don't forget this is also 24.5 and this is also 43.6. So it looks like we're going to be adding. We're going to be adding. It's just going to be a squared plus b squared equals c squared. There's no subtracting. The top one was subtracting because we weren't looking for the longest side. This, we're looking for the diagonal, so the longest side. All right, let's go put the 24.5 and the 43.6 in and determine what c is. So we get 2,501.21 c squared. And then we have to take the square root of both sides. And that gives us 50. So therefore, the length of the TV or the diagonal length is 50 inches. Go ahead and try to figure out the perimeter and I'll give the answer. So pause the video and let students try this out. So here this says 12.5 meters. This is 13.4, and we're trying to find everything on the outside. All right, so we did a squared plus b squared equals c squared in order to find this hypotenuse here. So we get 10 squared plus the 12.5 squared to get your hypotenuse of 16. Then add all the sides to get 65.3. All right, take care, have a good day. And have a good weekend. Hopefully see you guys back on Monday. Take care. Bye.